Thank you for that great introduction, and welcome, ladies and gentlemen, and thank you for the opportunity to present this keynote at the SiC AGM. The title of this keynote is Systems Engineering and Thinking. Being a whole room of engineers and being an engineer myself, I thought what I'll do, instead of just taking the traditional definition that you can find on Google, and there's a lot of definitions for systems thinking, I was going to use a practical mining example to explain to you what systems engineering and more specifically systems thinking in the mining industry is in your context. A mine is a set of interconnected activities. So you as managers, GMs, engineering managers of a mine are actually managing a complete system, and those systems are interconnected and those systems impact each other. And really the big question is, and that's what I'm going to use for this case study, is what can those set of interconnected activities generate as the system throughput from that system. This could be an open cast mine, an underground mine, a coal mine, a gold mine. It doesn't matter what type of mining commodity this or mining method this is. The interconnected activities always apply in terms of the dynamics of a system. So if we took this mining value stream or value chain of drilling, blasting, loading, hauling, crushing, processing, and an output, and we on average achieved 100 units for each of those, and we had designed the system like this, we're planning on achieving 100. What do you think that the overall system will deliver, take into account the underlying variability in performance or operating performance of each of those activities in the value chain? So if you have a look at that average of 100 production units for that an activity, and you look at the independent performance of an activity. Now, when I say independent performance, what I'm referring to is that performance of that activity when it's decoupled entirely from any up or downstream activities. So in the traditional sense, if that production activity had a 90% availability and was expected to do 100 units in a specific time frame, there was the mean, and on the left-hand side was a minimum of, say, 89 production units, and on the high side 111, and the traditional normal distribution, probabilistic distribution. But in reality, the distribution looks very, very different. There's still a mean, but as you can see, there's a very, very long tail going to the left, because in reality, there are 0 production days, meaning 0 production is produced in some days due to breakdowns and other internal delays. So there's a whole element of downside risk, if you want to call it that, where there may not be any production, and that has a major impact on the overall system when you put that whole system together. On the upside, there are still good days. You could go as high as 111 as an example, where there are no breakdowns, no internal delays. The shift started on time. The operators were all there. There were no delays at all from an internal perspective. And again, the important point about this is the independent operating performance of an individual activity. Importantly, each of those activities in the value chain or value stream may have their own unique probability distribution or performance envelope. So there are 3 examples. On the left, we've got one with a very long tail to the left. So in reality, there's very little spare capacity on that activity. Activity 2 is a normal distribution, and activity 3 has a lot of spare capacity. Its average is 100, but its upside is very high. So there's opportunity if you start looking at some of its internal delays and maybe some of its breakdowns, you could push it up entirely. So if we now put that together and take into account all the variability distributions or variability in performance of each of the underlying activities, activities that make up that value chain, in essence is actually going to deliver half. If the availability was only 90%, and assuming just the normal availability calculation, you'd only produce about 53 units. Now, in reality, depending on the shape of those curves and the degree of variability, it could even be lower than that if you run a proper simulation of that value chain. So, in reality, to understand exactly how that value chain performs, you can only do that by running a simulation to understand the dynamics of the flow of material through that value chain. In the motor industry and the aeronautical industry, they run a lot of simulations for their plants to get the optimal performance out of the plant, out of the manufacturing process. There they call it a digital twin, where they really run scenarios and optimize the process to understand where the constraints on in the impact of dependent and independent variation on that overall system. Now, importantly, every single system has a constraint. There is no system that is infinite. They all have a constraint. You can decide whether, if you design it, you need to design a constraint in. Unfortunately, in the mining industry, what I've found is that most of the mining value chains have actually been designed as balanced system, because there's a perception that is the best way to balance your capital cost of construction, and that results potentially in an unstable system where the constraint is continually moving. But let's assume that we can identify the constraint, and in reality we would be able to find a constraint in operation. In this instance, for this example, I'm going to use hauling as the constraint. So hauling is now constraining that whole value chain. And let's understand how we can impact that system's throughput by understanding where the constraint is. Now, the only way to understand that system properly, as I said in the previous slide, is to actually run a proper simulation model, which is not a very difficult thing to do, and it's easy. Now, what's important is that we need to focus. If you go to a mine, you generally find a list of hundreds of initiatives that are being done across the mine. The GM has got a long list of initiatives that he's busy managing and looking at how the individual ones are doing. But what we really need to do is focus. Now, that's not to say we ignore everything else that's happening. We still operate all the activities as they're intended to operate, but from a continuous improvement and a optimization of the throughput out of the system to achieve the maximum, we need to focus, and we need to focus attention on where the constraint is. So now, looking at hauling, what are our options? Now we're focusing on hauling. What are our options? The hauling activity in itself is actually a system. It's a subsystem within an overall system. We need to focus. I've represented all the output KPIs and input measures in a value driver tree. The output KPI out of this hauling activity is the capacity, or the tons per period, in this instance per shift. And that is made up of the direct operating hours, how many hours that equipment operates, and the throughput rate, which is tons per hour of that piece of equipment. There's also another lever, which is number of pieces of equipment. If you have a look at the direct operating hours, it's made up of available hours, it's made up of unutilized hours, and obviously the throughput rate. So looking at number one, you look at available hours, that's made up of calendar time, your planned maintenance hours downtime, and your unplanned maintenance downtime. Now that's the focus of the engineering function on a mine. And the aim here is to make the equipment as available as high as possible. The equipment must always be available. Its availability. To achieve that, you look at prioritizing your planned maintenance and eliminating breakdowns and increasing reliability. If that is your constraining activity, you want that activity to be the highest possible availability that it can possibly be. Importantly, it must have a very high reliability. It's no point having high availability, but you're responding to breakdowns very quickly, because that inherently produces variability, which impacts the whole system throughput. So it's really about improving availability. Now, this number two would be, well, we must utilize that availability as much as we can to get as much work out of that activity as we can. So if you have a look at the unutilized hours, it's really made up of the external delays, which would be a water delay, geotech, power outage, unrest. Internal delays, which are related to the internal activity itself. Maybe there's no operator, maybe there was a lunch break or something that happened that delayed that internal activity. And then there are the consequential choking and starving delays. So importantly, you want that activity to work as much as it can. It's now available. You want to use 100% of that availability. To do that, you need to buffer it from the other activities. So if this was hauling, it's now able to operate and it can't be loaded because the load is down. That is immediately a consequential downtime. It limits the load, hauling's ability to do work. Likewise, if it is loaded and it delivers to the crusher and the crusher's down, it cannot deliver. So, on a lot of mines, they'll say that you cannot put in stockpiles because it's seen as double handling and adds in cost. But in specific value chains, depending on where the constraint is, to go and add a stockpile between hauling and crushing, and even though it costs more to do double handling, the upside value is significant compared to the small cost that's been spent. Number 3 would be improve the operating cycle. Now that really drives to the efficiency of the cycle. So here you're looking at things like your bucket full factor. You must push that bucket full factor to the highest that you can. So what it's really saying now is get the most tons per hour that you can. You've got availabilities at 95%. You're utilizing 100% availability. Now you're going to make sure when that truck is taking each load in its cycle, the bucket is at 100% full factor. Also the cycle time, the speed's full and the speed's empty, and anything that's interrupting or making that cycle longer in terms of potential queuing, congestion, all those types of things will actually lengthen the cycle time. So that's the third area that you need to look at. So availability, utilization, and then the actual throughput rate, which is the improvement in cycle. Number 4 would be if you've exhausted all opportunities to get that equipment to run or sweat it at its maximum, you'd have to go and spend money and buy more equipment. Now, generally on a mine, you'll find that the first thing they do is buy more equipment. We need more trucks, we need more drills, we need more loaders before looking at how we can actually improve it. Now, importantly, you've got to understand which lever within those 3 silos and then the 4th silo actually yields the greatest improvement in the capacity throughput of that constraining activity. Once you've done the first thing, you move on to the second thing. So you don't have this long list of initiatives. You basically have one thing to do. When you've improved that, you can move on to the next thing. So to manage this whole system, there's more than just the interconnected activities in this system. This system consists of the operational planning activities. Now, those operational planning activities need to also pay respect to the system dynamics. So when you do operational planning, it must take into account the parameters around the constraint, how the constraint's impacting the system, so that planning takes the constraint into account. The support activities must also understand the system dynamics and focus on that constraint. So, for example, the complement at work in HR must focus on the constraining activity, in this case, hauling. I wrote a case study a couple of years ago about some work we did for a client where hauling was the constraint, and over a 24-month period, they had 19,000 hours of downtime just for one reason, and that reason was no operators available. So you had a truck was available, it was maintained, and now it didn't operate because there was no operator to operate it. That 19,000 hours equated to 118 man months, which was just 4 operators per month. And the general manager had not approved the 4 operators because he said it was going to cost too much. They were cost cutting. And it was shown that potential loss of opportunity revenue or profit was in the range of 2 billion rand because they didn't want to spend the money on 4 operators. So there's a simple example of how the incorrect decisions and the incorrect KPIs drive the wrong behavior. All the maintenance activities need to be focused on the constraints as well. When all those job cards come out of the planned maintenance system, whether it's SAP or any other system, you don't just start at number 1 and work through your planned maintenance activities. You must focus your planned maintenance activities on the constraining activity. Now, they start to say you let the other activities have breakdowns and issues, but they must be subordinated in terms of priorities so that you focus on the constraining activity, you increase its availability. If it has a breakdown, you also prioritize that activity. The roles and levels of work within the organizational structure need to also focus on that constraining activity, not forgetting the rest of the system, but from a priority perspective. Now, imagine operating a mine where the constraint is known, all the levels of work, the KPIs are all aligned to knowing where their constraint is. The management focuses on the constraint. The system is stable. You're now no longer running around fighting fires. You've no longer got management pushing down short-term priorities the whole time around why didn't we comply with plan? Why is there spatial compliance issues on the mine? And we really become more strategic. That really means the KPIs must be aligned. If the KPIs aren't aligned with systems thinking and aren't aligned with understanding the overall system throughput, where the constraint is, you end up, you measure what you get, what you measure. And if you're measuring the wrong thing in terms of management KPIs and who's accountable for what, that's what you're going to deliver. The alignment also of work and management routines. And it's also important to focus the senior leadership team on the strategic and the frontline management on the tactical aspects of the mine. What we're finding in the mining industry is that generally everybody is looking backwards. We're trying to understand why we never achieved performance yesterday. We're trying to understand what were the reasons and the causes, but we can't impact yesterday. You can learn from yesterday, but you've got to apply it forward. And we've got to change it around where our GMs and our management are actually spending at least 75% of their time looking forward to make sure the right resources strategically are available so that the frontline supervisors can actually execute and meet their plans. And then importantly, all the data is required to support the system and the underlying systems. As you can see from what I've shown you is that, for example, just to manage hauling, you only need 8 variables. We don't need to put sensors on everything. We don't need to spend millions on Internet of Things and massive digital solutions because we've got more data than we currently even use. I'd say we don't even use 10% of our current data. We do have the data to performance manage our mines properly and get maximum return based on our current realities around understanding systems thinking. So putting that all together, I mean, really the mine is a system of operational planning, the execution of that plan via a whole lot of activities with the correct allocation of resources. They're supported then by the technology, the data feeding into an organizational structure with the appropriate levels of work, clear defined responsibilities, KPIs that are clear in terms of your role, whether it's forward-looking, tactical, so that you can make the right decisions to manage that overall system. Thank you very much for listening. There are my contact details, and please also feel free to have a look at our mining knowledge portal that we're building to help drive collaboration and knowledge sharing in the industry. And a lot of the stuff I mentioned here is actually also available on the portal.